Monday, we learned already about the performance of the array. We know when the operation for the array is to add elements. So in order to add the elements, then we know that the time complexity will be On. If we remove one element, then the complexity will be also On. And for the space, do you still remember space? Space means the place to save the data. Space means the space to save the data. So how many space you need to save the data? And in this case, the worst case is n. So if you have 5 data, it means you need to have 5 space. If the data is 10, then you need to have 10 space. So that's the meaning by ON. Now, in an array, there's an issue, we call it the growable array. And there are two kinds of strategy to deal with this growable array. In an add operation, so if we learn from the previous, we can have add or we can also do like the insert the object at index I, okay. Or maybe the previous one we use also add. So we want to input in the index I the object O. So we can also do the addition with only adding the object. So if we use add O without any index, so it means that we will add the element at the end. So if I have data like this one, 5, 4, 6, 2, 8. Okay. So I want to add, let's say 9. Okay. Then the new data will be 5, 4, 6, 2, 8, and 9. So the new data or the new element will always be at the end of this array. So when the array is full, let's say I know that when I have this array, what is the length? When I have an array, we have the length. So the length here is 5. When we want to add a new data, when we add a new element, it means the array should be extended. So the length should not be 5, but the length should be added by 1. After we add the length plus 1, then we can add this element. So this is the meaning by we replace the array with a larger one. The question is, how large should the new array be? So if you have the command in Python, you still remember append, extend. What is the difference between append and extend? That means we will add one element. Then we will add one or more than one element. So you can add 1, you can add 2, you can add 3, and so on. In this case, if you just use the append. Okay, we can add 1. So if the length is 5, then we will add 1, then the length becomes 6. If the length is 6, then we add 1, and length becomes 7. But how about if you want to extend? So let's say the length is 5, and then we want to add 3 new elements. So it means we need to add 3, and then it becomes 8 for the length. So this kind of things is tedious job. So there's a question: how large should the new array be? Should we add by 1, or we call it the incremental strategy? So increase the size by a constant c. So for example, c. Let's say c equals to 1. Then it means every time you have a new element, you will add with 1. If c equals to 2, then every new element you will add the array with 2. Or we can have doubling strategy. So double size. Let's say now the length is 5. Okay, because I have a new element, so be the array length 10, regardless the number of elements to be added. So in a mathematical way, we can see this is the algorithm. Now, when you have an O object that you want to add into the array, so at first you will check T equals to the S length minus 1. So T, this is just to know how big is your array. Then the A, or this is an array, let's assign a new array of size n. So we will assign a new size of an array, and then we will do the loop from 0 until n minus 1. And for every s, so s is the previous array at the index I, let's move it into the new array. And after we move into the new array, so let's assign the s. Now the s equals to all elements in A. And then we will do the n equals to n plus 1. So it means we will add the array with the n, it means the data with 1. And then at the end of the s index, we will add the object O. So this is the object O that we want to add into the new array. Now we need to compare the strategy. We compare the incremental strategy and the doubling strategy by analyzing the total time Tn needed to perform a series of n at 0 operation. So we need to check if we want to add an object to the array with incremental strategy. This is the first strategy. And we want to compare it with the second strategy, doubling strategy. So we assume that we start with an empty stack represented by an array of size 1. So let's say we have an array and the size is 1. Let's say I have 1 element like this. So we call average time of an add operation the average time taken by an add over the series of operation. So the formula will be something like this one. Tn is the number time taken to add the elements divided by the number of elements. that we have in the array. Let's see, like this one. For the incremental strategy, we replace the array k equals to n divided by c. So n is the number of data, and c is the constant. Constants mean any number. Constant is any number that you want to do for the add operation. For example, I want to add 1, then c equals to 1. If I want to add 2 elements, then c equals to 2. If I want to add 3, then c equals to 3. So we can see the timeline of a series of n add operation is proportional to this equation. So let's suppose at the first time we have n data. We have n data, and then we want to add one element. For example, c equals to 1. Let's say c equals to 1. Then we want to add one element. And then after we add one element, we want to add another element. Means there will be 2c. If we want to add another element, then it is 3c. If we want to add another element, then we have 4c. And so on until we have kc. So until k times. So if this operation happens, so every time you add the element, and you add the array, then we will have this series. So you can make the series simple by using the formula. So c plus 2c plus 3c plus 4c and so on. So we can simplify into mathematical like this one. C multiply by 1 plus 2 plus 3 until k. And then if you know the arithmetic progression, so if you learn the arithmetic progression, so in the arithmetic progression, we can have this equation equals to this one. C k, it will be multiplied by k plus 1 divided by 2. So this formula, it is obtained from this one. Now we can check this one. This is c multiplied by k multiplied by k plus 1. Then we know that using this formula, it will give you, if c is constant, then the operation time for this incremental strategy is O n, this is this n, the data, plus k power of 2. By k power of 2, c multiplied by k multiplied by k plus 1. Then it is k power of 2. We know for the big O notation, n plus any lower order, it can be simplified into this one. So we have O n power of 2. The amortized time of an add operation is O n. The amortized time, what is amortized time? We have this one. The amortized time is the formula Tn divided by n. And we call this amortized time or the bridge time. To add C element, to add elements with the incremental strategies, with C, it will be O n. So the amortized time is Tn is n power 2 divided by n. Divided by n. Then it means this is n. So the number last time is O n. Now let's see if we use the doubling strategy. What does it mean by doubling strategy? We will replace the array k equals to the log 2 log base 2 n. So the total time Tn of a series n operation is proportional to this one. So when we have the array with n elements, so when we want to add another element, so let's say this is one time, and then we want to add some other elements, so we want to add two times, and then after that we have 4, and then after that we have 8. So this is a doubling strategy. Double, 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 16, and then 32, and so on. Then we can have this as the geometric series. This geometric series means we have the 2 power of k in this case. So if k equals to 1, then it's 1. If k equals to k equals to 0 is 1. K equals to 1 is 2. K equals to 2 is 4. K equals to 3 is 8. K equals to 4, 16. K equals to 5, 32. And so on. So we have 2 power of k. So this is the geometric series. We expand the array two times, bigger and bigger. And when we do this one, because it is the geometric series, the formula will be like this one. Power of k plus 1 minus 1. So if you still remember your mathematics, 1 plus 2 plus 4 plus 8 plus 2 power of k, it will be equals to this one. And when we have this formula, so let's replace k equals to log base 2n. 2 power of log base 2n plus 1. So with this minus 1, so at the end, we can have Tn minus 1. If we have this 3n minus 1, it means this is On. So if we have On, the amortized time, which is Tn divided by n. So the Tn is n divided by n, then it will be 1. So when we use the doubling strategy, the big O will be O1. Which one is better? Doubling strategy or incremental strategy? Versus doubling strategy. In incremental strategy, we have the amortized time is O n. For the doubling strategy, we have it is O1. And we can say that doubling strategy is better because the amortized time is O1. Meanwhile, the incremental strategy, the amortized time is O n. When you create an array, when you have the add operation, it will be better to use doubling strategy. So this is the code. I think you can see the code in the Jupyter lab. So Let's see. Yeah, this is about the array-based sequence. You learn some operations and you learn about the growable array. Let's see the code in the should be the lab. So this is the code given by the book. We have the diamond dynamic array. This is a class. So I hope that until now you know how to understand the code. So this is a constructor. N equals to 0, capacity equals to 1, and then we want to make the array. Okay, so if you still remember, underbar N. Why we put the underbar? Okay, this review the materials in the object-oriented programming. In the OOP, I teach you this one about the encapsulation. Okay, so this is to avoid the privacy issue. So we want to protect this one. So we want to protect the variable. So this to make it as a private variable. Okay. So this is the initial value. And then we want to check the length of the array. We want to know the item of the array. So if the index is in between 0 until n, then it's fine. But if it is not in between 0 and n, then it is invalid index. Append. So append means whenever I want to an element. So this code means if the n or the data equals to the capacity, then it is not enough. So we want to resize. Resize means we want to grow the number of space in the array. In this case, I want to double. So I use the doubling strategy. Double the capacity with the method resize. What is method resize? So method resize is here. In the method resize, we want to make an array. So let's make a new bigger array and then move every of existing value A into B. And then after I move every value into B, so the B will be equals to A. And the new capacity is C. So after you have this resize, then the A of the new length will equals to the object. So it means the new object will be added into the A. And then the n will be added by 1. So this is just to make an array. It is not a public method. If you still remember, when we have the underbar like this one, so it is private method. This is just to make the new array with the capacity C. And then we have the insert. So insert means I want to insert into index K a particular value V. Here we will ask if n equals to the capacity, then resize. In this case, I use the double strategy. Using the double strategy, we will multiply with 2 for the capacity. And then again, we will shift. Okay. We will shift the rightmost first. After we shift it, then Yeah, we will add the new value into the particular index, which is the k. And then we will add the n by 1. If we remove a particular value, so what we need to do is we will do the looping. We will do from the index 1 until the index n, and then let's check if the index k equals to the value. So if index k equals to this value or not. If it equals, then at first we will do the loop. The loop is to shift. So what we learned from the removal, if the array here, let's say this is index 0, index 1, index 2, index 3, and then index I. And then we have index I plus 1, and so on until we have index n. So if I want to remove this one, then it means the index I plus 1 will go here, the index I plus 2 will go here, the index n will go here. Then it means we will shift the other elements to fill the gap. So we need to do the loop. And at the end, the last index will become node. The last index will become node or empty. And then n will be minus by 1. If we cannot find any value, then it is value not found. Okay, so this is how we can do the removal, how we can add the object into an array. Okay, that's all about the array. Any questions?